Hey there, welcome back to another probed episode. It's April 26, 2025. We're on dry dock day 27. Today, we're diving into a hydraulic valve remote control system feedback issue that popped up after recent valve renewals. Three hydraulically controlled valves in the ballast water system are giving us trouble. 1. Low suction valve 089. 2. High suction valve 090. Both serving tank cleaning pump number 2. And 3. Ballast water system bypass throttle valve 026. All three valves were mechanically renewed during this dry dock period. But now we're dealing with feedback indicator problems. The remote control panels are showing incorrect open and close indications, a classic post-maintenance issues. We'll start with the digital feedback circuits for valves 089 and 090. Then tackle the analog position feedback for valve 026 in the end. So grab your multimeter and let's troubleshoot some feedback loops. Let's probe it on.
I saw the name immediately. I knew this is the guy. Again.
See you next time, mate.
See you.
Good
Thank you
luck.
very much.
Bye.
We have a problem now with this indicating valve. This is tank cleaning pump suction from low C chest and the high C chest suction. It's working fine. Opening indication, valve close, close indication, but here at close valve position, no indication. Valve open indication is good. This is the problem. Let's go and find out.
This is valve 089 and below it is valve 090. First, let's check what type of position indicator are fitted in these particular valves. For valves 089 and 090, we have VPI-E and position indicator. This version gives you a visual position arrow and electrical limit switch feedback for end positions that is fully open or closed. This is great for simple binary status signals. It is commonly paired with a TC block for temperature compensation, though it also works with a PTC block. This helps to compensate for the low temperature and pressure of the hydraulic oil to offset the sluggish movement when viscosity is high or the pressure is low. Let's calibrate both position indicators of both valves. Notice that the arrow position of valve 089 is not fully reaching the closed position. So let's start with the 0 setting or the closed position. Let's turn it slowly counterclockwise to make the indicator start at 0 or close. The cam should touch the micro switch to the right when it reaches its minimum position. For valve 090, it should be the same process. Now let's test at the remote panel here at cargo control room.
Close position now. Open. Open. Close again.
All good?
Not yet. It's not closing. It's closing, but the indication is not.
But this cabinet
Switching.
is somewhere in the engine room, yes?
Yes.
With the solenoids.
Yeah. Need to calibrate more. The indication is that not reaching the close micro switch.
But this micro switch also in the engine room, yeah?
Yeah.
It could be adjusted there.
Yeah. But if not, we should adjust on the valve itself. But this one I have repaired already. Before it was the same.
Okay.
I calibrated this one earlier. The problem is with pressure and temperature. If you have cold temperature and low pressure,
I'm going so quick actually.
yeah, it will have some delay or not enough force to push the indicator. Right now it's the same. See?
Yeah, that's okay.
For valve 090, it looks okay. The valve feedback issue doesn't end here, it's time to probe deeper. Safety note, before proceeding, ensure proper isolation procedures are followed. Let's remove the electrical supply to both solenoid coils of valve 089's opening and closing so that we can operate from here manually. Let's open the valve by manually pushing the 3 to 2-way valve here. Let's mark the connection plug with O for open. And the other with C for close. To close the valve, simply reconnect the plug since the last command from the remote panel is to close. but the cam of the shaft indicator is not reaching the micro switch for closing. Let's remove the shaft and try to overhaul it. The shaft is loosened and moving freely. For some unknown reason, one of the two rubber sealing O-rings is missing. The missing O-ring allows the outer shaft to slip independently from the valve stem, breaking the mechanical coupling needed for accurate position feedback.
I think we know now the problem is this shaft with this missing O-ring, and when it is spinning it's loose. And the calibration is now offset if this is loose. Let's go to this store and find some spare. This is old. We can look inside if the O-ring is still there. old shaft, but it's still hard. You see the O-ring is still intact. This is the difference. The O-ring. We will use this shaft, although it's old.
Let's put it back using the shaft with an O-ring from the old spare parts. And calibrate it by opening then closing and vice versa, while checking the turning limits of the cam between the two micro switches.
Now it's good.
It's good? Which one? Ah,
Yeah.
okay.
2 down.
That is, I think, what then? 89 and 90, yeah?
Yeah.
Alright. Good.
This is the problem.
Which one is the problem?
Ooh. This is the old shop. See what's the difference.
Yeah, what is this missing here?
Some o-ring.
Yeah.
That's why it's loose.
Ah, yeah, okay, just missing, yeah, and that's
Yeah,
it.
that's it.
Okay. That's strange, yeah.
We don't have new spare of this indicator.
Okay.
We can order one.
But this one you changed, huh?
Yeah, I use this.
Yeah. Alright.
Now for valve 026, it is located in the other cabinet. This is it. This valve uses the VPI-C type. Visual plus continuous analog indication. It gives us a visual arrow and an analog output through a potentiometer, allowing continuous position feedback, not just fully open or closed. This is ideal when you need real-time valve positioning, especially for 4 three-way valves or systems that operate at intermediate positions. It's typically used with a PTC block for compensation, but it also works with a TC block if needed. The usual signal range, approximately 300 ohms when closed, and somewhere between 850 to 1700 ohms when fully open. Let's open the position indicator and take a look inside. Inside is the potentiometer, the core of the analog feedback signal. After cleaning, we refit the shaft, the gear, and the indicator cover. Now with the multimeter in resistance mode, we'll calibrate the close position at around 300 ohms. For the open position, it should read between 850 and 1700 ohms. Let's check the remote indication. At the CCR remote control panel, valve 026 shows 100% open. Same reading here at the BWTS remote control panel. Back at the local indicator, we reset to minimum range or closed. It should measure approximately 300 ohms. Then we reinstall the cover and align the arrow to point at the closed position. Next, we reinstall the glass cover and finally reconnect the connector plug.
Is the valve open now?
Which one? Yes, that 100 is open. I cannot tell you what is the actual position now, but 100 is open, 0 is closed.
Can we close?
Yeah. Try to do it like several times. Well, like this.
Here is blue.
Blue.
It's open. That means open, right?
Yes. Well, it's not closing then.
Because I set to 0. It's the transmitter. We can also adjust here 0 and 100%
Okay.
potentiometer.
But then for that you need to know what is the status out there, eh?
Yeah, we need to
The actual
see
status.
the actual status there.
Strange that this doesn't match this one and that one. How is this possible? Because this is blue there.
Blue means
Ah, but
open.
yeah, 100. This
Yeah.
is this one, eh?
Yeah. So can we close?
Oh, you see? I was
Ah.
opening, now it goes to 0.
And there,
Yes, closed.
it's closed.
Yeah.
So the potentiometer is reversed.
You think so?
The according to
Ah, you
manual.
see now I close, it goes to 100, huh?
Yeah,
Now I
the
open, it goes to 0.
yeah. That means the potentiometer that I followed from the manual,
Yeah,
300 ohms is at closed position,
yeah.
1.2 kilo ohm is at open.
Yeah.
So that should be reversed. So now it's when you
When
put
you turn to close, it will open.
Close.
Now you turn to close. And now it's going to open position.
okay. So can I put to open? I will look at the local indicator.
Yes.
That should be open.
In the engine room, eh?
Yeah. Here is close.
Open,
Looking at the local indicator, it shows open. Now we unplug the connector again. And measure the resistance at the current position. Interestingly, the remote panel shows closed, but our reading here reflects the open position. This is the resistance in open position. Let's adjust again, slowly turning counterclockwise until we reach the minimum range, close to 300 ohms. Here's the struggle, trying to maintain that precise value while reinstalling the cover. It's a delicate process. We reconnect the plug and check again.
Open. Turn to close. Nothing. Turn to open maybe. Nothing.
I will close and check the local indicator.
If it's closed. If it's changer.
Earlier, we saw 400 ohms before switching to close. Now, after operating remotely, it changed to 1129 ohms. So we reset again to the minimum range. In this kind of analog calibration, patience is a trait you need to develop.
See?
I think it is closed, the actual position is closed. Eh?
Yeah. Actual position is closed.
Yeah, I was in the pump room. Huh?
So, yeah, resistance now is 300 ohms. Should be 1.8 or 1.7 kilo right now. So I will adjust.
Now I'm turning it back to the maximum range, the open position. But here's where mistakes happen. Several times I forgot to reconnect the plug before checking the remote indication. So we came up with a better plan. We'll start again from the beginning. Set the potentiometer to the minimum range, 300 ohms. But this time, I've reconnected the plug so the signal reaches the isolation amplifier. From here on, I will calibrate locally, while Chief Officer is monitoring the remote indication via video call.
Hello? Can you put the video on? Yeah, can you show me the panel? Okay. Now I will move to maximum.
Okay. So now it is closed. Can we open it?
Yeah. Fully open. Blue, yes.
No delays.
No delay.
Just have to confirm with that. Going smooth.
Smooth.
Yeah.
And
Also there, yeah.
close, black.
Yeah.
All good. No need to adjust here.
Okay.
Yeah. There are two ways. There
There.
and here. The 0 and 100.
Yeah. Very nice.
The problem, it's not connected. That's why we are getting any signal. I only realized when I tried many times up and down.